Good morning, everyone, and welcome to the first of our 2021 webinars. This time it's all about cavity wall ties, evolution and corrosion, 3 decades of change. I'm your host, Andy Ferguson, and today I am pleased to welcome Bryan Hindle of Brick Tie Limited. Good morning, Bryan.
Good morning, everybody. Nice to see you. Welcome to Yorkshire.
Oh, yeah. For all those that have been tuning into our webinars on a regular basis in the past, well, gosh, it feels like we've not done one of these in absolutely ages. But again, and as always, a big hello to you. If you are a new listener, a big welcome to you. And in addition, I know we've got quite a few international listeners on here. Whatever daft o'clock that might be, wherever you are, I just want to say a big thank you for tuning in to us. Now, guys, while we're just waiting, I'm just going to go over some general housekeeping things. If over the course of the webinar that you want to pose any kind of questions, if I can firstly point you over towards that facility. Now, if you're on a desktop, that will either be on the left or the right-hand side of your screen. Simply, basically, click on the wee box that allows you to kind of make a comment. There's a send button in there, and we will see your comments. Feel free to just jump on the announce, give us a wee hello and tell us where you are. If you're on a mobile device, that comment section will just be a little bit just below. You just need to pull your screen up just that little bit, and you'll see it within there. There is, however, other ways in which you can pose your questions. You can either email me direct, and I will pose them to Bryan at the end of the webinar. It's just at andy@property-care.org. That's andy@property-care.org. Or alternatively, if you are so socially savvy, you can go via one of our social media channels, either through Facebook, Twitter, or LinkedIn. Just use their native search functionality, find us, Property Care Association, and send us your message. Just a note as well, because I know it's going to be a busy morning, that for those of you who might have a problem, and it does happen from time to time, it is 9 o'clock in the morning, everyone is switching on their computers, and with all the homeschooling, it's not uncommon for people's internet to fail. First thing I would suggest is please do just refresh your screen if you can. Hopefully we come through okay. Worst case scenario, if all hell breaks loose and you just can't see us, there will be a recording that I'll be sending out in the next day or so. So just while we've got a little bit of time just to kill, I just want to give some news from the PCA. Some of you might be aware of some of these two new things that I'm about to actually say. A lot of you will not, but recently the Property Care Association launched 2 new tools. Firstly, I'm going to talk about our new BMI surveyors tool, Building Moisture Index surveyors tool. Now, I have to say, for those of you that have not come across this is a groundbreaking piece of kit. This is a surveying tool, 6 years in the making, in partnership with UCL, University College of London, and through intense research and detailed studies, this has led to effectively an internationally recognized and academic praise for the research and developed into this new BMI surveying tool. And I do promise you, there's nothing like this in the marketplace. For any of you that come across condensation, mold, and excess moisture issues, this is a diagnostic and reporting tool you want to know about, especially if you are a PCA member. Now, to find out more, visit our website. It's on the homepage, or alternatively, just go to property-care.org/BMI tool. Second thing I just want to say quickly is our new online surveying course. We recently just launched this as well. This is a 6-week course, 35 hours of learning, including 10 live training broadcasts, 12 pre-recorded online learning sessions, 6 interactive sessions, and a stack load of professional trainers. Now, I have to say, after months of hard work and as a team, we are delighted with what we've managed to kind of pull together. And going by the inquiries so far, you guys are as well. Now, if this is of interest to you, visit our website or go to property-care.org/online surveyors training. Just to let you know, though, there is a big waiting list. So if you are interested, please do get in touch with our training team to get on the waiting list. That waiting list is first dibs on all upcoming courses. Also, as well, look out for our structural waterproofing and invasive weed surveying courses coming your way over the next couple of months. I suppose, Brian, on to yourself a wee bit. I mean, we've got about 2 minutes or so just to kill. I mean, first thing, how are you, good sir?
I'm very good, thank you. It's raining like mad up here in Yorkshire, but apart from that, it's warm, and things are going great up here.
Oh, that's nothing new. I mean, just look at it as pennies from heaven to a certain degree. That's a terrible thing to say, isn't it?
Yeah. Well, you know, hard times, but you've got to look on the bright side, haven't you? That's the way to go. So, it's God's own county, so we're all happy up here.
Well, I suppose when you come and live in Scotland, you've just got to get kind of used to the rain.
Yeah.
It's with the
midges. Yeah.
Yes, joy.
Yeah, the midges as well. You've got to watch out for them.
I actually learnt something about you quite recently, Brian. I mean, as well as you've been an expert in all things wall ties, I actually heard you're a pretty good amateur photographer as well. From what I hear from the girls in the office, you sometimes drive them daft taking pictures with all your gear and stuff like that. From my hair days.
Yes.
A bit of a cheek to talk there with my hair looking like Wizzle Gummy. But I bet you're the sort of chappie that's got all sorts of camera whiz tech lying about your office.
Well, we like our toys, don't we? And when you're passionate and interested about something and you've got the opportunity, you do like to go out there and get all the bits and pieces. And I know a lot of the guests that are coming on here will have oodles of kit. That's what we like. And it's the same with photography. It's the same with damp proofing, wall ties and anything else. Andy and Ross and all the other guys and Russell and all those in the industry, go to their offices, you'll find a stack full of kit because we all love it because it all helps us do our job. So, yeah, same with photography. Yeah, I've got lenses galore and all that kind of thing. I love to see good photographs, whether it's wildlife or rusty wall ties. That's what we like.
Well, here, folks, a big welcome to everyone that's just kind of joined us. Yeah, you're through to our featured presentation today, which is all about wall tie evolution corrosion, 3 decades of change. We are about to start. Now, just for those who joined us, if you do want to pose a question over the course of the webinar, simply all you need to do is use the chat functionality. On the desktop, it should be to the left and the right. If you're on a mobile, you can pull up. Alternatively, you can always email you any questions you've got just to me at andy@property-care.org. That's andy@property-care.org. Well, Brian, I can see that is nicely bang on 9 o'clock. Wall tie evolution and corrosion, 3 decades of change.
Yes, indeed.
That's a big title. But I suppose what exactly has changed, and what are the challenges that now faces, and what exactly should we be doing? Some big questions there, Brian. I suppose without further ado, over to yourself, good sir.
Good morning, everybody. Welcome to Yorkshire. Thank you, Andy. Okay, so let's go to the first slide. What we're going to do is we're going to go through the period very briefly, actually, because it's a long time. We're going to start back in 1985 when corrosion was known about, but mainly by the BRE, and the boffins out there knew about it, but there weren't many people dealing with it, and there was very little guidance on how to deal with that problem. So first of all, let's just look who was in charge when we started out. So the Iron Lady was the Prime Minister. That's how far back we're going. All the way through to when we got the Donald, okay, the big orange guy over there. He's gone now. So been a lot of changes over that period. Wall tie corrosion has gone through a lot of changes. It started out basically as a niche market and ended up a huge industry at one point, and then now it's fallen back again. But the importance of corrosion is that it's a semi-structural defect. I know that sounds a little bit of a fudge, but you'll see exactly what I mean as we go through. Just a little note about that. It's not, things don't change, but some things don't. Kylie Minogue was #1 at the time, back in 1985, and she had a #1 hit last year as well. So there you are. The little pixie from Australia, Pixie of Pop, is still going strong. Sorry about the reading, guys, but these are this is the agenda. We're going to start on wall tie corrosion, the traditional view of it, how things were. I know that we've got a selection of members here. We've got PCA members who know a lot about wall ties, so I'm sorry we've got to go through some basics for you. We'll get to some interesting things hopefully later. But we've also got students and residential surveyors, commercial surveyors. They need to know a little bit more about corrosion. So I'm going to cover you guys too, hopefully. So bear me with that. We'll get on to the changes, how the industry had to evolve, because initially wall tie corrosion, it was just about wall ties. We weren't worried whether properties had cavity wall insulation. We didn't have any guidance. In 1988, the guidance was issued, but then it was reviewed in 93, and things started to move on. In 95, we got BRE 401, which is a fabulous document with a lot of useful detailing. 2000, we saw further reviews, and every time this happened, we had to change. Okay, and I'll bring you forward onto how things are done now. So back in 1988, having been in the industry 2 or 3 years, I got a copy of BRE 329, issued in 88, and at last we had some guidance. Okay, and that guidance was great for us because at last we had, from Dr. DeBeeke, who wrote it, we had an outline of a range of wall ties we could use. We had, it set out methods of dealing with rusty ties, because there's all sorts of things. You can take them out if they're rusty, you can isolate them, which I'll explain. You can grind them out, and there's cropping back. There's all sorts of things. I've even been on jobs where a particular local authority wanted us to take bricks out and physically burn the tie off at the face of the inner leaf with a blowtorch, you know, with a acetylene. So there've been all sorts of other things. That's not mentioned, by the way, and it wasn't in BRE 329. So I'll just move on a little bit, and we'll just show you why wall tie corrosion is important. It's important because the external leaf, as you can see here, could fall off. Now, I know there's a disconnect here between the title of this, the robust nature of construction, and the pictures you're looking at. But I really mean it. Traditional construction is incredibly robust. And for any students out there, the cavity wall and the way we build houses is a marvellous thing, you know. And as you can see, this property's lost maybe, 30, 40 metres of the outer leaf. But the inner leaf, the structural leaf that holds the roof up and the floors and the grand piano, whatever's there, that's still there, all right? So structurally, we're okay, because traditional construction is very forgiving, okay? It's brilliant. The outer leaf is just a cladding, it's just a weatherproof panel, all right? But it's got a slenderness ratio of maybe, I don't know, 50:1. If it didn't have the wall ties, if it wasn't borrowing that lovely rigidity and support of that inner structure, that nice cross-section, stiffened building, it would flap about in the wind. And that's exactly what's happened here. Interesting thing on this is you'll see sometimes in structural engineers' reports, people talking about taking precautions to avoid the wall unzipping. And there you see what happens. When you get a collapse, it might only be a small area of the wall that's affected. Usually right at the top where there's an apex perhaps, or near a corner where there's a funneling effect of wind going past, you get negative wind pressures. And what can happen is a few bricks will pull away, but then it's like a runaway train and it peels the outer leaf down. Some of the debris will actually drop down the cavity as well and force it down further, so you get this unzipping effect, okay? So we'll just get past that. I know it's a bit, it's quite rare, by the way, don't have nightmares, but it does happen occasionally. All right, why does it happen? You might think it happens because the tie just rusts straight through and snaps. Well, that's true, that does happen. But often, when we deal with collapses and things, what we actually find is the ties are still sticking out of the wall. You know, the outer leaf has fallen off, but the inner leaf is still there with the old tie sticking out, and they feel quite chunky. And what's really happening is, as the tie rusts, we get a lot of expansion because ferric oxide takes up a lot more volume than the original metal. And it's in the bed joint, the weight of the walls there is resisting it. And as you can see in this image, the tie's in pretty good condition in the inner leaf, and then you've got this expansion in the outer leaf, okay? So this is probably one of the photographs we were talking about earlier. It just shows it nicely. You can see how fat that tie's become as it's expanded. And it's constrained by the weight of the wall, but it's a chemical reaction. You won't stop it. It only needs water and oxygen to happen. There's plenty of that about. So you get this splitting, okay? And that weakens the wall, all right? It weakens it considerably, even though it's not initially disturbing the inner leaf. all right, because you've got these horizontal cracks. We're no longer dealing with a homogeneous panel that all acts in unison. We're dealing with horizontal strips of wall all the way down. And we get this horizontal cracking, which we can see externally. It's a bit of an iffy picture, but it's nice because it shows how an owner of the properties pointed them up, and that's highlighted them very clearly for us, okay, so we can see them. It's not always just horizontal cracking, and that's why I use this slide as well, because you can see the horizontal cracks, they're all happening at the tie positions, and as those ties have rusted, and they've all rusted at probably a similar rate over the years if they were inadequately protected, but the ones right at the top where there's a lot less weight, a lot less load, they will have caused a hairline crack maybe 30 years ago. And of course that hairline crack has sucked in water under capillary action initially. It's not driving rain's not to do with it at that stage, it's just pulling moisture in, and so it gets faster, and that's why corrosion is usually worse at the top of the wall, because the exposure of the ties has been increased by the cracking. So we get the horizontal cracking, the wall's moving up, the outer leaf is growing, and it's restrained in certain places. So if we look at the corner on the left side of that image, we can see some stepped cracking. So wherever you get points of restraint, either because there is a reveal, any kind of external or internal corner, or because there's anything in the inner leaf projecting across the cavity, you might then start to get stepped cracks, okay, because the section of the wall there is in tension. Be careful with that. We're not structural engineers and building surveyors. If this guy had only pointed up the step cracks and not the horizontals, you might be forgiven for thinking you maybe had a bit of settlement at the corner, and that's why the brickwork were in tension there. Or conversely, it might have been a bit heave in the middle. So there's no law says a house only has to have one problem. It might have wall-side corrosion, but it could just as well have other issues too. So always take good advice on that. Now then, these horizontal cracks can be quite big. I'll give you two samples here, a rendered on the left and a naked one on the right. If we look carefully, we'll see we can actually see through at the reveal of both of them. That's why I chose these pictures. These are big open cracks. Just think about what you would be looking at if that property had cavity wall insulation. Actually, the one on the right has, but the thing is, when you've got cavity wall insulation, the last thing you want is a lot of big cracks like that leading into that insulation. If it's a southwesterly elevation, or exposed site, water's going to be streaming into that insulation. So on the left, 6 mil crack, the tie was only 3 mil thick, it's trebled in thickness. On the right, 3 mil crack, it's doubled in size, that 3 mil tie. So this is not unusual. You might read about them getting 10 times bigger, etc. But in practice, there's weight on the wall. You don't often see that. Well, I've never seen it. Okay, so let's move on to another slide for you. What other things can we look out for? So looking out for horizontal cracks. Bear in mind this is only fishtail ties. We'll come on to butterflies in a minute. You don't get much horizontal cracking with butterfly ties and little wire ties. So here we've got a gable wall. So it's an unrestrained gable, i.e. it's not got coping stones running up and down it or anything like that. The wall simply, the roof simply overshoots the verge. And you can see the ridge there. It kicks up like an oriental pagoda. And that's literally because the outer leaf has grown in comparison to the inner leaf. And if you've got 2, 3, 4 mil cracks gradually widening all the way up the wall, because usually it'll start at the top and it'll march down the wall over time. As I said, starting as hairline cracks well before anybody sees them. Marches down the wall, you can get 30 mil, 40 mil of growth. So now the ties at the top are sloping down to the inner leaf, aren't they? Which we don't want. But also, so you can end up with corrosion on the inner there, but also we're getting all this disruption. And in fact, we're applying load. So imagine if we had a row of coping stones there with weight on them, that weight would now be on the outer leaf. So the outer leaf starts to resist that. It's not designed. I mean, this one in particular, big high gable, the slenderness ratio of the external leaf is 100 to 1, all right, because it's 10 meters high. So very thin. You start putting weight on that and you're getting this. If you look on the right, there's some step cracking at the edges, and it's gone straight through the verge detail. Because remember back in these days as well, the water being ties laid at the verge. So just glance at my notes, trying to do that without anybody noticing. But yeah, one thing important about this particular thing is this, as we'll get onto, this job had a guarantee on it from the Remedial company. It was done in the 80s. And they didn't isolate the ties. And that's what happens, similar in other industries, when you get suddenly a new thing and everybody dives in. We might see that with retrofit insulation. You never know. Everybody dives in and suddenly things get missed. And there's loads of jobs like this around. We've got horrendous horizontal cracking. Poor clients had to pay for it again because they didn't isolate or remove the original ties when they put the new ones in. We had to do it all and do that. Okay. Just beware when you have got coping stones, because it will disrupt them. It will open the perps. It will let more water in. If the flashings on the inner leaf, obviously they may cause the inner leaf to get wet and the insulation to get wet. Okay. Sticking with cracking for a while, obviously it applies to rendered houses. It destroys the render because once you've got all these horizontal cracks, it will start to debond. So it's been a boom time for specialist renderers and external finishers. On the left side, I'm just showing there, just demonstrating to you, you're sticking it's a fine crack that. It's only about 2 mil, 1.5 mil, 2 mil. You can stick a penknife in, they go right into the cavity. On a hitched roof, which on the left that one is, for those of you who don't know, it hasn't got an apex at the gable. It all goes up to a nice sloping roof, so that's a hitched roof. And many hitched roofs in my area, the rafters project all the way through, and then there you've got a fascia board nailed to the end with the with the gutter on, which is brilliant. But those little rafters are not designed to transfer load to the outer leaf. They transfer load to the wall plate on the inner leaf. The inner leaf is load bearing. Okay, that's the load bearing leaf. When the outer leaf starts to expand, and it only needs to expand a few little millimeters, you will get the load being transferred to the roof. And this is why sometimes on hitched roof houses you will see horizontal cracking, step cracking at the corners, and you might start thinking to yourself, oh, they've got a roof spread problem, they've got other issues. It might have other issues, lateral restraint issues and such. But the wall-type corrosion induces bulging at the top because now we've got a thin outer leaf trying to push the roof up. And of course, it can't bulge inward. The ties are still quite strong in compression, but because, and there's a twist there, etc., but because they've got this mucky glove of rust on them, that sort of acts as a lubrication. The wall can just move out. So be careful there. Okay, so on to surveying. Bear in mind the butterfly tie, top right, that is on this image, the butterfly tie is not going to cause much in the way of cracking. It can cause some cracking if the bed joints are thin, if they're brittle, cement bed joints. But generally you don't get a lot of expansion cracking because you've not got a lot of metal. Fishtail ties it's the other way. So boroscope, fantastic piece of kit. And just for you that haven't used boroscopes, what you're looking at is you're looking at the wall tie as if you're looking up a tube, and the bottom of these images is the inside face of the outer leaf. All right. So where you see the tie at the bottom of the image, it's going into the bed joint of the outer leaf, and you can clearly see it. That's where the rust is worst. Usually it's worst at the intersection, but also within the outer leaf. So we've got a fishtail on the top left. That's a bitumen coated fishtail. Not much bitumen coating left on it. That is very average for what you look at on pre-war houses where bitumen might have been used. Up here in Yorkshire, I know it's different all around the country. Up here in Yorkshire, it's about 50-50, something like that. Actually, I've got some figures that show that's not quite the case. I've only just done the hot off the press. I'm going to show you them later. So on the top right, we've got a galvanised wire tie. In our area, normally post-war. But I've got some experience of other areas from years ago when I used to have a little franchise organisation. I won't bore you with that. But some of those guys are still up and running in their own businesses. It's fantastic. And in Manchester, for instance, you don't often get fishtail ties. You get a lot of wire ties and thin ties. So this varies across the country. So forgive me sometimes if I tend to be Yorkshire centric. All right. So at the bottom of the image, we can see some insulation in the background. We've used a bit of compressed air there to blow into the cavity to try and make a space so we could use our boroscope. Bit hit and miss that, but it shows you how some of the challenges we've got nowadays with insulation. And you can see the ties there are terrible, rusty as hell. Okay. Actually, as an interest, this might be a good time to maybe look at having a little poll, putting a poll out there, because butterfly ties, post-war buildings, we've got various things we'd probably like to talk about there, and we'd like some input from you as to how you feel about wall-tie corrosion as it's changed across the years. So hopefully, Andy, if you're there, if you could send that little poll out that we discussed that might be useful.
Yes, guys. Well, here, just to let you know, I've just pushed the poll out to everyone. The question is, have you ever encountered wall-tie corrosion in post-war property? Hopefully it's just popped up on your screen. I'm going to give it about 10 seconds just to allow everyone to kind of respond. I know there's sometimes a little bit of a lag. Results are fairly interesting coming through at the moment in time, Brian. I'm not going to say what the results are just yet. I'll give it another couple of seconds. So 5, 4, 3, 2, 1. And I'm just ending the poll there. Well, Paul, just in case you can't see the results, Brian, the big answer was sometimes, and that's at 45%. Following that was rarely at 21%, followed very close behind with never at 20%, and only 12% saying many times.
Right. Okay, that's interesting. That's really interesting, because I've got some little figures for you to, as I said, fresh off the press, that we've done. Only last week I asked the girls an awkward question, and they dived into our files and got me some data on the proportion of properties we've been looking at with certain defects. So that might be useful for that. Okay, so there's your boroscope. Back in the day, that is all we basically used, but a boroscope can be very misleading, and I'll just go on to that here. So here we've got a boroscope view of 2 ties, all right? On the left-hand side, we've got a galvanised tie. On the right-hand side, we've got a galvanised tie. Different ages. Actually, the left one's post-war. The right one's pre-war. The right one's also in a black ash mortar, if you're keen to look at that. You see there's a black ash mortar there. I've highlighted some corrosion on them, but it's not particularly bad, is it? We've got a little bit of greying of the zinc before then on the left-hand side, before we start with some white oxide, which is basically rusty zinc, zinc oxide. And on the right, a similar looking thing. It's a bit out of focus, that one, but you can see a little smudge on it. Some people might say, oh, early stage corrosion, monitor it. Things are quite good. Let's carry on. However, be careful with boroscopes in this situation, because if you look at this slide, on the left there, that's again a post-war property, and on the right, that's a pre-war property with black ash. I'm going to give you a sample above. One on the left, from memory, I think that was a skull that we looked at, a sort of 70s built skull. It's got cavity foam insulation in it. If you were looking up the cavity with a boroscope, you would see white oxide. You wouldn't see any rust. You might see a tiny bit of rust pitting. In the outer leaf, all that's left is a rusty stain on the underside of the brick above, as you can see, where the latents just pulled off when the brick were removed. On the right-hand side, galvanised tie there, well galvanised, often pre-war properties, you've got to bear in mind. These are primitive, little workshops. Sheffield were full of them back then as well. And on all the cities across the country, hot-dipped wall ties ended up sometimes with twice the amount of zinc you needed. Never mind, not enough. It's only post-war that we find there's not enough on them. So in this case, again, you would only see white oxide if you relied on your boroscope. And so in some respects, I liken a boroscope to an electronic moisture meter, because, and how much have we debated that over the years? It's all down to the judgment, skill and experience of the surveyor. It's not what you see is what you get. Just like with a meter, if you stick a moisture meter in one, you get an eye reading, that just is there to attract your attention. It's now your job to find out what's really going on. And it's the same with a boroscope. I would say one good thing about a boroscope is they're very good for me as a contractor, in that when you look up a cavity and the tie is horrendously rusty, it's a job done. It's a Chris Peckham opportunity for me. I'm rubbing my thighs with delight. It's great. So they're great at condemning ties. If the ties are rusty, you can confirm it very quickly and easily with a boroscope. But if the ties look pretty good, often you need to go a little bit further to protect yourself. Okay, so we'll go to the next slide before we get on to a little bit about apps. I'm going to talk about protecting yourself with a boroscope when we get on to insulation. Just before we leave corrosion, don't forget lots of timber frame houses out there. In Britain, we don't like, we're sticklers for tradition, aren't we? So mainly post-war. But by and large, they're just as bad. We come across loads of corrosion issues on timber framed houses. But also they have an issue with more, if anything, and numerically they are less common, but they actually relatively have more problems than a normal cavity wall. And that's because you've introduced additional things for the traditional builder to do that you weren't used to doing. It does seem when in construction, the further we diverge from tradition, the more mistakes we tend to make on site, I find, because people are not given the opportunity to be trained and then to build up skill. It's just, we're doing it this way now. So if you look on the left there, the tie is just nailed with a single clout head. When the outer leaf is flexing around and being blown about by the wind, it buffets and it lifts up and down. Corrosion causes the outer leaf to grow, and that little frame cramp style tie there can act like a nail bar in that situation, pulling the nail out with it. You can see the top right image. We're looking at the back of the Spooner dwelling there. It is a type of timber frame building, and we've seen that the ties were just nailed, single nail, to the sheathing, not to the studs. And that sheathing flexes around, and again, that buffeting pulls a nail out. And bottom right, the corrosion on post-war timber frame is often horrendous, because we're getting now, the accountants have taken over since the war. We're all short of money. Does it sound familiar, this? We're all short of cash. Oh, the world's ending. Cuts. That transmits to how much galvanising do we need? We're only going to put on what we have to, what the standard says. And the standard, as it turned out, was wrong. All the way up to 1981. Not enough zinc were put on, particularly with timber framed houses that have galvanised plate, galvanised straps, because they just bend them, and as they bend them, it cracks the zinc. So, as I said, sometimes it's clear. There's boroscope images. One on the left, it snaps. Nobody's going to argue with the report on that one, guys, are they? That ended up a full removal in a genuine reason for a full removal, because the ties in the inner leaf were rusted so badly. It was causing cracking on the inner leaf as well as the outer. So that's a full removal strategy, no doubt about it. We're going to move on at some point to other defects, and I just want to reassure everybody that the cowboys are still with us, and they've always been with us, because on the right there, that's a pre-war property, and they've run out of wall ties, so they've used nails, all right? 6-inch nails, and it's insulated. You can see there's insulated where we took the brick out, but we only took the brick out to photograph. Right, let's move on from that one. Just get my notes in. Make sure my notes are here, because I don't want to forget all the little things that you need to know. Okay, so when we're talking now about how to deal with corrosion, all right, I mentioned full removal, didn't I? All wall tie jobs, well, yes, nearly all wall tie jobs are a 2-stage operation. What we're going to do, we've got a house with rusty wall ties in. Well, they're no good, they're rusty. We're going to have to put new ones in. In this discussion, I am not going to bore you with all the different kinds of wall ties there are, simply because it takes forever, and because I would have various manufacturers jumping all over me saying, why didn't you mention mine? Right? So we're not going to deal with that. But basically, there are loads of different wall tie methods. I've written about them on my blog in the past and all the rest of it. They've all got the place. There is no magic bullet on wall ties. Nobody can say, oh, just use this one, it's fantastic. You need to consider the building carefully, the substrate, the width of the cavity. Lots of things need to be considered. I've put a link at the end that you can go and have a little read about wall ties if you really want to get into how they actually work. So let's concentrate on dealing with the old ones. If we leave the old rusty ones in, we're going to get more cracking, it's going to get bad in, it's going to carry on and carry on. That chemical reaction never stops, does it, until there's no metal left. So back in the day, on the left, we used clamp sleeves. We used to pop them over the end of the tie. As time went on, people started using other methods. Clamp sleeves are literally, you chase the bed joint out, you put the sleeve over the tie, you repoint, and the metal at the end can expand into the little expansion pocket you've created when you've isolated it. It involves using a breaker chisel. On the right is another way of achieving a similar thing. This were all outlined in BRE 329 and updated as time went on. It could be fresh air in that void. It doesn't need a clamp sleeve or anything else. It just needs to be there so that when the pointing's put in, we don't re-encapsulate that tie in mortar, because it'll just crack again. All right, so the rusty stub is left behind. Okay. With wire ties, often we can leave them alone. Not always, but often we can leave them alone because there's very little metal and you don't get the same extent of cracking. So where are we in the industry? We've got the original BRE and we're moving along since 1988. And in 1990, some information papers were issued that just puts it in perspective for you. So it was predicted that by 1979, over 50% of the ties in pre-war property would have lost their protection. In other words, they're starting to rust. So that's the maturity of the situation then. You know, that's 40 years ago, okay? So 40 years ago, the coatings were going. All right. Now, back in 1979, I was listening to Ian Joy on a cassette tape in my car. That's how long ago that is. All right. We can't have any cassette tapes. Sadly, Ian Joy's been and gone, but he was brilliant. Anyway, so we'll move on from that particular bit. Next one, post-war building room housing is at a particular risk due to material shortages. I'm sorry to read these to you, but this is important because post-war, the standards were being obeyed, if you like. So now, if you're going to galvanise something, you're going to galvanise it to the standard. And the standard was defective. So they do not generally have enough zinc on. And so their lifespan is much lower, okay? We're all getting old. I was 25 when I started in wall ties. I'm 60 now. Ties are getting old, so it's never ending, okay? So in 1993, out of the blue, only 5 years after it was first issued, BRE 329 was reviewed. And it came as a bit of a shock because what they did is it was a minor tweak as it happens. It was still only 12 pages long, BRE 329. But bang, what it said is cavity wall insulation should be considered. And we never considered insulation in the past. It wasn't on our radar at all. Most houses didn't have it. We just did a wall tie job. It was no. But in this document, they then said to us, when you are working on a house with insulation, we should fully remove all the ties. And full removal is a very onerous operation, okay? But we were told this is what you should do. So it's time for a bit more evolution, isn't it? If companies want to survive, they have to adapt. Now, Brick Tie, he did the call. You know, I heeded the call. And there's no advert for my firm, by the way, but I'm sure everybody else had similar problems. We suddenly think, oh, we've got to remove the ties. We nearly went bust because we didn't win any work because the price of the job was so high and the consequences of the work so high because it's very invasive, apart from being very expensive and time-consuming. It's very invasive. All the insulation in there is going to be disturbed and then patched up. I think the insulators now would say, you're not doing that, you know? So it was a problem. So what we had to do is we had to adapt. And we looked at BRE and we found that we could grind back ties. And so we carried out experiments and we found that if you grind back ties, removing the bed joint and the metal in the outer leaf, you don't contaminate the insulation so much. Okay, so when you see CWI, by the way, it means cavity wall insulation, just to let you know. And that became a problem. But at that time, we didn't have a lot of houses. But BRE knew that a lot of houses were about to be insulated. And during that time, the insulation was being given away, wasn't it, by local authorities and power suppliers. So we started investigating how to, in effect, carry out work on a house with cavity wall insulation in without ruining the insulation. So grinding out the bed joint. Okay, that was the first thing. Now in 1995, BRE 401 came out, and at last we got real detail because what we'd been missing was how to survey properly, how many ties to look at, how to visually grade rusting ties. Okay, what were the recommended action based on that? None of this was in the original standards. Didn't actually told you how to do wall tie work. Didn't tell you how to survey it or how to judge things. It gives guidance on tensile proof loads, which is marvelous. Getting ahead of myself. How many ties to test? What tension to place on those ties, and that had been lacking up to now. Okay, so it's a very important document, very welcome to us. So in that document, at last it gave us. It removes some of the subjectivity from wall tie corrosion because there's a table in there. Table 2, it tells you how to go down and you find the description that most fits the tie you are looking at. There should be several ties, but the tie you're looking at. Number 1 being mint, perfect condition. Number 9, rusty as hell. Okay, so you've got 1 to 9. And then another table you can look at, table 4, and that will tell you what you ought to be thinking about recommending based on what you've looked at. Sounds simple, doesn't it? Great. Now we only use the right-hand side because we're using visual means for the ties. We're not doing chemical analysis. So use the right-hand side. And as you can see, usefully, it's got best action and minimum action. So in other words, the best thing you should do, if you look carefully, to fit remedial ties from just when the zinc is slightly corroded, which sounds quite, draconian on the face of it. The minimum action being inspecting 5 years. But even there, you've got to schedule repairs if there's any red rusting, and fit remedial repairs if there's any erosion at all. Okay, and that's the minimum action. Now, when is best and minimum appropriate? There's some guidance I've highlighted in yellow. This really does sound like it was written by Donald Trump. Listen to this. Take the minimum option only if all the samples are the same corrosion level or less corroded than the worst. I don't know what that means. Anyway, so we always apply best. We always recommend best, especially on a pre-purchase survey, but we make the client aware that there is a minimum. That's being fair. Okay, so let's look at the corrosion levels. So there's a little game now. We're going to just go through these 8 slides, 2 on each. This is turn 1 of the bumper edition. And this, for your information, is all on a post-war property. This is a commercial property in Yorkshire. Slightly different. Ties are the same. Ties are exactly the same. Come out of the same factories of all the other ties, galvanised to the standard at the time, the appropriate standard. So the manufacturer's done nothing wrong. Okay. What we can see there is what look like very good ties. Embedded, dovetailed in the inner leaf because it's got a concrete structure. Embedded in the outer leaf, a little bit of discoloration. That's just a little slide there for you students. That's how those buildings are wall tied or were then. Okay, you've got this channel embedded in the formwork. When the formwork's removed, your bricky can literally just shove his tie in and wherever he wants. And then you've got a deformed section, a drip feature in the middle. Let's look at the next one now. There's some boroscope information here too, because I've removed the perp here, though, the perpendicular joint between the bricks, so you can see up the perp, but I've done that for demonstration purposes. What you would see on the left there, everything below that little blue diagonal line would not be visible. So all you would see is that little rusty patch that you're looking at there. That's all you would see, okay? No visible loss of section, tiny bit of red rust pitting, best and minimum are what we're going to do. If we pan back a bit and look in the outer leaf, we can see it's very, very rusty. We can't tell whether there's loss of section, but we can see it's very rusty. Post-war property. This is another tie, same building, okay, and now we've got the red rust pitting highlighted on the left, just as the tie enters the outer leaf. It was raining that day, and you can see how wet the outer leaf is. I were up a cherry picker at the time, but anyway, so we've got, if you look, it's also useful when you're looking behind RE401, it's got them nice, you think grey, what do you mean grey, darkening of the zinc? This is a good example of zinc corrosion. You can see these different patterns. The inner leaf is getting wet as well because of the amount of mortar droppings on that tie. It's transferring some water to the inner leaf. I'm not worried about that in this case because that dovetail system, the tie isn't actually embedded in anything. It's just in a slot of metal. It can expand and rust. It's not going to be an issue. Same building. Okay, built in 1970, by the way, or in the 70s. That's as close as we can get for this one. More corrosion, red rust pitting, all the rest of it. I think you condemn that with the boroscope anyway. But again, look at the left. This is the same elevation of the same building. We've got the twist tie. On the left, you've got that difference in zinc, and on the right, red rusting. The one on the right, obviously, it's a job. The one on the left, you'd look at that, and I'd recommend replacement because I know what it's going to be like in the outer leaf. But we do see situations, independent surveyors, and looking at that, saying, "Oh, it looks all right to me." So be careful with the boroscope. Now, this is definitely a Chris Peckham thigh rubbing job. If you look on the left, it's failing. If you look on the right, it's a very close up, but that is absolutely destroyed. So we've got to turn it up to number 11. They only go up to number 9 in BRE 401, but that's an 11 in there. We didn't have to use a boroscope there. However, if it had been insulated, we would have had to. I'll get onto that in a minute. So, need to move on quickly, I think, or we'll run out of time. Post-war buildings, just as an example, this is the same building, okay? Sort of similar sort of corrosion happening to the zinc. That's the inner leaf at the top there, and you can see the upstand of that has pulled the concrete out with it. In sort of testing and parlance, that's known as concrete cone failure, okay? Where in effect, the fixing hasn't failed, the substrate has failed. It's pulled it out. Ooh. And it's just warming on, we've got 10 minutes, we better get on. So concrete cone failure shouldn't happen on lightly loaded fixings like that. They're only taking probably 1 or 2 kilonewtons at the most. So it's very likely that this job was shot fired. And shot firing ties into concrete is a big no-no, because when you shot fire the bolt in there, it can cause micro cracking and stuff in the material. So these ties probably failed, very quickly. And it's a total failure because they're not connected securely to the inner leaf anymore. This is just below parapet level, same property, same building, left-hand side, poor embedment. We can see the fishtail end, it's barely in the wall. It's a slip plane, that, because they've laid them dry underneath a cavity tray at the parapet. The one on the right's interesting because I turned the light off of the boroscope, and so it's lit by the sunlight shining through the cracks. Very dangerous and not as uncommon as you'd think. Getting onto wire ties, they don't cause the cracking. If it's post-war in particular, they will be galvanised to the inadequate standard, and so be very wary. And here you can see again boroscope images. This is a 1970s school, and the corrosion is horrendous. Okay, right. The awful truth. I know this is possibly another chance for a poll. The awful truth is here. This is what I had the girls do last week. This is 100 wall tie surveys, all next to each other, not selected. They're just, right, I just said to the girls, go back 100 wall tie surveys. So this is a tail end of last year all into this year. What type of tie? What level of corrosion? So we can see that we've got 57 of those had galvanised ties. 57 of the 100 had galvanised fishtail ties. And of those, 80% were corroded, okay? And bear in mind, my surveys are not on commission. They're not there to sell anything. We take photographs of ties, so the photographs are there to see. So I think these are probably pretty accurate. If anything, there'd be an underestimate, because when they're insulated, the lads have to drill more holes and faff about and chase bed joints out and all sorts of things. And boys will be boys, and maybe they might not see them thoroughly. I don't know. I'm not looking over the shoulder every minute of the day. So there might be underestimates. So we've got 57, 22 bitumen coated, all of those 100% rusty. Butterfly ties, only 15. That's a low number, isn't it? So in my part of the world, that means those were probably post-war. And of those, 11 were corroded, so 73%. So although we were asked to look at fewer of them, they seem to have just as big a problem. Mixed, well, we'll go into that. Sometimes, especially in the 30s, they've got both types of tie on site. They're through stores and things. Just to help you, if you don't like figures, there you are. On the left-hand side, galvanised fishtails. Blue, the numbers looked at. Red, the numbers corroded. Bitumen-coated fishtails, butterfly ties, mixed. Okay? So it gives you an idea of that. Right, quickly, let's get on to failures in new construction and defects that are not related to corrosion. That is a standard wall tie, stainless steel. The bent bit should be embedded in masonry. It's about 50 mil long, roughly. None of it should be visible in the cavity. This is what we find very commonly. You would be amazed how common this is on post-war multi-story blocks, domestic residentials, where things have gone a little bit amiss, and we've ended up with 25 mil or less. Okay, left one is a residential property. All right, that is bent to tie down the cavity. The right one is a brand new school. You can see the date on the thing. It's 2019 that was looked at. You'll remember a few years ago, some walls fell off gables of things, fell off gyms and whatnot up in Scotland, and a lot of my fellow PCA member multi-specialists made money out of that, which was great. We all have. And so we've looked at a lot of schools, and this is what you often find. Okay. This has been known about for a long time, so I know I'm not telling you anything new. If we look at the bottom there, that BRE information paper gave us that drawing in the middle. It's well known. Why is it still happening? Why are we having these ongoing problems? I would say nobody knows, but I'll get onto that. Top right, be very careful when the outer leaf is natural material like stone, because the front face may be plumb, but the back face will be all over the place. The poor brick has got to build it nice and neat. And if the ties have gone into the blockwork in advance, but long enough, or they've put them in too deep, you get that poor embedment. All right. So, bring us up to date. We're running out of time. Cavity wall insulation. Inspection can be carried out with a boroscope with some compressed air. Big blowout bulb, you can often get some views. And as I say, if it's a done deal, i.e. if the ties are rusted, they're rusty, you know, so boroscope's great for that. But of course, if the borderline, or if they look bright and shiny, you need to chase a bed joiner, okay? Or remove a brick. Some people like to do that. I don't think removing bricks is a good idea with insulated houses because the insulators don't like it. So chasing beds out is good enough. Left-hand side, nice rusty wire tie. Right-hand side, horrendously laminated and rusty fishtail tie, okay? So BRE 329, that's 20 years ago when they last reviewed it and they touched on this. Fig 1 shows you the amount of spoil introduced into the cavity when we install new wall ties. So by considering the drilling method, the hole diameter and its position, you can reduce that spoiling. We've been doing this actually since the mid-1990s. I'm saying we as in brick tie now, but I know some other people did that because we had to adapt. Because BRE 329 back in the past was telling us to fully remove the ties. So we had to adapt because clients will not pay for fully removing the ties unless there's obviously rust on the inner leaf, you know? So how can we protect the insulation? Modify your drilling pattern. But they still recommended in that document, consider a full removal strategy. Okay, and a full removal strategy is expensive, time consuming, and should only be done if there is genuine corrosion on the inner leaf. That is a personal view. Now, I don't want any clients saying to me, you've ruined my insulation and my house is damp because you've done the wall ties. So we've got to be careful. So we're going to move on now to remedial failures very briefly. I'm running out of time. Andy's probably pacing. That's a remedial job where the ties have been put in. Nothing wrong with the make of tie there. They're great for certain applications, as most are. But the guys turned up and banged them in, probably bought them on the internet, didn't know what they were doing, didn't have the right equipment. Only discovered after they basically discovered that the wall ties were in wrong, shouted at the contractor who then put some more in, and now we've got to shout at him again. But it also applies to specialists, especially in that Klondike gold rush of the sort of 85 right through to, well, to present day almost, really, because there's no supervision. You get this. The top left there, the tie's not hardly in the inner leaf. Next to that rather blurry image is an unexpanded mechanical. The next to that on the right, we've got a mechanical that's over-torqued in the inner leaf and split the brick. Another one that's loose in the hole. It happens with resin and all sorts of other things as well. I'm not picking on mechanical ties. Bottom left, over-torqued in the outer skin and split the brick. And right, that's the most common defect, actually, only one picture of it, but it's people not isolating the original tie. They've pretended to there and it's just cracking through the repairs. Very common. Can we fix it? Yes. There are training, there is some training. I don't think anybody's offering this at the moment. I wish they would because I'm running out of employees. They're getting old. They're my lads who've got this. We've got 3 or 4 left. So testing can get us out of this. We've got to test. And it's not done enough. So lots and lots of tension tests with calibrated rigs. Hydrojaws supply ours. They even supply electronic rigs, which we use now on high specification anchors when we're testing. These encrypt the data. It can't be messed about with and it's there forever. Brilliant. It will trickle through to residentials as it gets easier to use. The Construction Fixings Association do courses on fixing technology and installation. It's very useful for technicians to know just how these things work. And also for surveyors on testing. I'm an advanced tester, by the way, which were brilliant. I commend that. Grinding the ties out instead of chiseling them out with a chisel is what you need to do. It will protect the insulation from being contaminated, and it massively reduces vibration exposure for your technicians by 85% on our data. All right, 85% less if you use that method rather than chiseling away. You'll still have to chisel sometimes if there's fall pipes in the way and there's ties in little reveals you can't get to with a big special grinding machine, then you need to chisel them out. To be fair, we have got data, just to give you an example, I think it's 169 now. Yeah, just to go into that slightly, I've not basically run out of time. Just let me finish this. From a health and safety perspective, specialists tend to have long careers. I've had one. And your men do. If you're looking after your guys, they'll usually be with you for decades. They need looking after. Their health will decay. They'll wear out, okay? And the law says the maximum HSE points is 450. It's 400, sorry, 400 a day exposure limit value. We have proven that with grinding, you will only get between one man 60 points. 2 men sharing a job over a day, 15 points each, grinding the ties. 450 points if you're chiseling them. Yeah. And even if you shared that work over 2 days, you're going to be getting over 100 each, which is over the exposure action value. So now you've got health surveillance and all the other things. So looking after them is important. And you'll get into trouble with HSE as well. I should have gone to that. I think that's Andy's. So sorry I had to get breathless at the end because I told you too much in the beginning. Oh, by the way, yeah, we've got 169 separate sites of data on watertight installation, drilling, and we found not as great a difference, but a big difference on if you install your ties in the bed joint, making sure it's suitable and your testing regime's there, then you can massively reduce your exposure, vibration exposure again. And that's the way we're tending to do it. So I hope all that sunk in. Fortunately, the PCA tend to do a little video so you can pick things up. But I'm very happy to answer questions about this subject. And I'm keen to know stuff from my fellow specialists in particular, because we all live in our own little bubble. I live in the world of brick tie. So I know an awful lot about a few things, all right? And I know I've got Fred and Dave Cook and various other people, and Andy, AD over in Phil London at Bar Group, loads of specialist contractors around the country, Ross Charters, etc. And we share our knowledge. So please share it with us. So I think we're about there. Thank you.
Well, fantastic. Yeah, well, Brian, yeah, firstly, many thanks for that presentation. Some real interesting results from the poll. And I have to say, the awful truth on wall tie corrosion was a bit worrying when you actually see the results. And that's 100 of them as well. And I think, lastly, who knew you could tie in Maggie Thatcher and Kylie Minogue into a wall tie webinar? But only yourself, Brian. Only yourself. Well, here, folks, firstly, many thanks for everyone that's been posing questions both before the webinar started and also during the webinar. Now, I am similar to other webinars. I don't think we're going to rattle through all the questions. So, Brian, I'm hoping you can maybe get through your answers as quick as possible, because I do have a stack load here of questions. I'm going to start with the email questions. If I put it into Scottish, two of these are belters, in other words, quite long. Now,
right.
I'm going. Now, the first question comes from Craig Smith. Now, it's actually quite long. I'm going to read it out and break it down to you, because he's really got 3 points here at the moment in time. So prepare yourself. So what Craig is asking is, and it's to do with wall ties for subsidence fixes. He's asking, I've heard that builders are doubling up using helical ties for remedial minor subsidence fixes within superstructures, effectively creating a helical beam to spread the load and stabilise the property. His first question as part of this is, 1, how effective is this? 2, is it even a mode of repair that we should be using? And 3, what do you think are the limitations of using helical bars for remedial work, for subsidence issues? Now, 3 questions there. 1 being, how effective is it? 2, is it even approved? And what do you think is in its use?
All right. I'm an Helifix approved contractor, so we do loads of heli beaming. So yeah, like a lot of specialists, we love heli bars, whether they're for helical, however, you know, as long as it's done properly and everything's considered. However, what he's referring to in effect is a type of overpinning rather than underpinning, you know. So you are transferring loads. I would say I'd worry about it, to be quite fair. You know, I would, because you have to be certain that the ground has stopped moving. If it's going to start moving again, you don't know how it's going to move. If it's going to be eccentric or whatever, it's going to move outwards and inwards as well. You know, I mean, I'm not an expert in the ground. My brother used to be, who was in brick tie with me. He's into that. Everything above DPC levels, what I do. Now we are going to do, hopefully at some point, a structural, a more structurally based CPD. And when that time comes, I think we could delve into this a bit deeper. So you need very specialised advice to do that. You're transferring loads to the inner leaf. I mean, okay, that's what wall ties do. We double up ties often you know, but usually it's because, for instance, we've got just high wind loadings between opposing gables, or, you know, we've got a slightly weak inner link. I mean, if you're doing tension tests, we do gazillions of tension tests. You're doing tension tests and you can't quite get what you want. One answer to that is just increase the tie density, you know, put a few more ties in so that they're all doing a bit less work. But yeah, I'm not being wishy-washy. I'm just saying it's a little bit, you could almost have a session on its own on that subject. Yeah. You really could. So watch this space. What's the third bit? Oh, the limitations. Limitations of Helibar. It's yes. Like any other products.
Well, no. In
workmanship defects.
In terms of it being for remedial work for subsidence issues like this, I mean, what do you think of the limitations? How far could you take it?
Oh, yeah, you could probably take it really far. You could put a lot in, you know, and it's a great technique. You're forming composite beams from existing masonry, you know. So you're giving it that tensile strength it never had before. And that's the thing. All these cracks, by and large, are tension cracks. Fill the masonry with post-installed stainless steel and flexible grout, because it has a little bit of flexibility. If you give it that tensile strength, it's a fantastic procedure. You know, I could go on for hours about all the different jobs we've done over the years with it. It's brilliant, but it needs to be designed right. It's not something that Joe Bloggs can just turn around and say, oh, let's just put some Helibars in. It's just a recipe for a disaster, you know. And plan it carefully. You need to talk to the manufacturer's approved installer for starters, because often the manufacturer wants to sell his products. Please don't shoot me, because he does. He wants to sell his products. The installer, usually, provided he's got some experience, will be that break on. I don't really like the look of this one. You know, so you need experience with that kind of thing. It's not something you just want to start throwing around. You know, you need experience contract to it.
Well, just moving on, because I'm conscious of time here. Same question, actually, again, is email from Aaron White. Again, it's a long one, so I'll try and break it up. Bearing in mind and how difficult it is to know what sort of wall ties are present and what state of corrosion that may have occurred on the wall ties without an internal investigation, do you think that all wall ties over that of 40, or do you think all cavity walls over 40 years of age should be subject to an inspection when a building is being surveyed? And should this inspection be done by chartered surveyors who then recommend appropriate remedies that can then be undertaken by a specialist contractor? Boy, oh boy, Aaron, that is some question.
Right. No, that's great, is that? No, that's brilliant, because we live in the real world. What I'd like is that all the surveys are done by an independent. When I started brick tie, all our inspections had to be done by an independent structural engineer. We used to pay the engineer to do the inspection. We'd go and act as his technician and knock holes in the wall. He'd look at it and tell us what needed doing. Because I've been in an industry that was self-specified for years, and I wanted to change. But as soon as wall ties became mainstream, and everybody is a wall tie expert, it was me too. They didn't want to pay us to get an engineer to look at it. So I agree with your question there, in that it would be lovely if we could have jobs inspected by independents, but it's expensive. Often, actually, it's the specialist who knows about the thing. He knows more about it because he's dealing with it every day. So, as regards who does the survey, somebody competent, who's got some ethics, right? So we want competence and we want honesty. This is where photographs and things come in. We need to reference the documents, and that's where BRE 4.1 is very useful, you know? So I don't want to get dragged into independent good, contractor bad. It's all about finding somebody who's honest and competent to do it properly, okay? As for doing what was it, the tail end of that? I didn't quite get it. What's the tail end of that question?
Okay, I mean, because I'm hoping just to try and cover a couple of more questions.
All right, go on. Yeah.
What I'm going to do is I'm going to try and group these.
Oh, sorry. It was about the age of properties. Yes, I think the data I showed you came as a shock. Because I'm very busy. I like ginger cats, as I mentioned before. You know, I'll see something new and interesting, and I'm looking at that. So I tend not to look back. And having had the girls look at those 100 surveys, even I was surprised about the level of corrosion on the butterflies. Just remember, in Yorkshire, butterflies are usually post-war. Those are post-war houses, and yet 70% of them had sufficient rust for us to recommend remedial work. And that means sufficient rust in accordance, not just with BRE 401, but common sense, i.e. the rusting. Yeah, and wire ties, remember, a thinner section. So loss of any section is more serious, okay? And you will not get visible signs. So you can't go around looking at post-war houses, your old Wimpeys and stuff like that built in the 70s and 80s, and say to yourself, oh, that's all right, looks good to me. This advice where we'll see it all the time, where in a report you'll say, a chartered surveyor will say, the house is of an age which may be subject to wall-tie corrosion, get it checked. It isn't checked. It's never checked there. Because straight away in the way that's worded, you've underplayed the problem. Either look at it or don't look at it. If you're going to look at it, tell them you need to look at it. All right?
All right.
The other problem is, of course, they're usually insulated, so you need to look at it properly. Because if you see just one or two, as you saw in that commercial building, you get a wide variation post-war. Pre-war, you tend to find if they're rusty, they're all rusty. But post-war, because of the poor galvanising methods, you can get a very wide variation in the condition of the ties on one survey. So it's important to look at as many as you can, and that's difficult with this cavity wall insulation. Right.
All right, well, here, folks, just kind of, I think we're going to run just a couple of minutes over. So if you can hold on, that would be much appreciated. Just after 10, Bryan, if I can ask you just to really keep these answers really short and sweet, we'll try and group these things. So I'm going to group some questions together here. I've got a couple of questions that came in via email and chat to do with surveying. Just tying them together, questions are related to if the wall ties don't cause cracking, how would a surveyor be able to identify the defect during a non-invasive survey? And also, if I add on to that, is there any common errors which result in surveyors mistakenly advising wall tie failure?
Yeah, okay. First of all, with wire ties, I'm afraid you're just going to have to use the age of the building. If it looks like it's post-war cavity construction, prior to 1981, I'm coming round to the view that they should all be checked. All right. There are other reasons why they should all be checked, because if they haven't got insulation in, they're going to get insulation soon. So you're foreseeing that there will be corrosion after the insulation is in, which will become a problem. So in the mix is these things. It's not just about the corrosion per se. It's also about thinking about the problems it will cause when the insulation is installed, especially external wall insulation, for instance. They're putting that on cavity walled houses now. Disaster if they put that on top of a wall that's got or is shortly getting a corrosion issue, right? As for problems, yes. I mean, I've lost count of the number of surveys we've been sent to do a wall tie inspection. When we get there, it's a solid wall. You know, so that's one thing. Don't happen that often now. But the other thing is, we do see cracks in walls, horizontal cracks caused by fixings, caused by thermal effects, depending on the position of boot lintels and things like this. If we do something on structural, I'll be able to throw a load of stuff in for that kind of thing. But yeah, there are other reasons. But let's face it, it's not the end of the world. If you send somebody along for a wall tie survey, most companies are going to charge, especially now, because it's more onerous. The things moved on. Back in the 80s, you could just stick a boroscope in, the rusty, end of problem. There weren't often, by the way, but there are a lot of people saying there were. I'm sorry I'm waffling out, so I keep it short. But the thing is, it's not a big deal to check it, right? Even if it's costing 75 quid, 150 quid for a contractor to do it.
Right, well, and this last question, this has actually been very popular. I've actually had 3 emails on this. There's been several posts stuck up in the chat here. But if you can give one-word answers here, just so I can tie off, it's to do with equipment. People seem to be really keen on any recommendations. Can you recommend good boroscopes, metal detectors, and what was the other one? No, it was boroscopes and metal detectors. Which ones have you got? There's been comments that people have been buying them and they're frankly pants. Any?
They are pants. No, the problem is that back in the day they were complicated and expensive and fragile. Now you can get digital ones which are very cheap, but they can be a bit flaky. You know, as a specialist, that doesn't matter to me because my business is crucial. So I just buy a new one when I break, buy a new one. So if anybody out there and my fellow specialists know of a really good and robust digital boroscope, I'd like to meet them, because the ones I buy, I'm not going to name brands here, but if somebody wants to drop me emails, I can have links and things to what I use. what's the thing? Metal detectors, Whites, who are my favourite metal detector manufacturer, have just ceased trading. So we've had to buy 20 right for our surveyors, right? Because we bought 20 because they've just ceased trading. So I'm interested again in my peer group out there, because I ain't the king of wall ties. I'm just one of these guys that knows. So that you guys who do wall ties regularly, if you've got a better handy metal detector than the Whites, I think it's the A10FF, A105 or something, that's the one I use.
All right,
you can't have one of my 20, by the way. There for us.
Well, guys, you heard Bryan there. I mean, he's interested in hearing your opinion with good ones. But here, just apologies if we didn't get to answer your question. What I'll do is I will pass them over to Bryan. And if he can, I'll get him. If he can get back to you, then absolutely fantastic. Guys, just a couple of things just before we go. Just some useful guidance for you. There is a code of practice on there. If you go to the PCE website for installing wall ties and lateral tie restraints. Bryan himself actually has a very informative blog. There is the link there. I will send this in the show notes at the end when I send out the recording. And also just to let you know that if you are keen to know more about cavity walls, we do have a training course on cavity walls, which not only focuses on failures with cavity wall ties, but also about the implications of cavity wall installations and impact of other forms of retrofit insulation. To find out more, just contact our training team on that. Just very quickly, just for those that didn't hear at the very beginning, we PC do have two key things that we've just kind of pushed out quite recently. The links are up there for it. First of all, our Game Changer, which is a BMI building moisture index tool. The URL is there. Just go to the website. Also, our surveyors training, just to let you know, this is currently fully booked out at the moment. If you want to get on the waiting list for this, which you'll get first dibs, please do contact our training team. And also, just to let you know, the invasive weed and structural waterproofing one are coming your way over the months to come. Last but not least, just to let you know, our next webinar is on the 26th of February. We're just waiting some confirmation details here, just on titles and etc. But I should have this out to everyone next week at some point, hopefully in midweek. But if you are keen, certainly go to the URL there and you will be able to see the webinars there. But again, I'll send an email out. Last but not least, I know that was a blitz, I just want to say thank you to everyone that tuned into the first of our webinars this morning for 2021. Hopefully we see you next month at the end of February. A big thank you to yourself, Bryan, for your presentation. It's been a pleasure having you on board this morning and you sharing your knowledge. And I suppose finally to all, I just want to say, well, I hope you have a lovely and fabby rest of the day, everyone. Goodbye, everyone.
Thank you very much. Thank you. Bye all.